Welcome to AI Peer Review. Today, we're diving deep into something I think is really starting to bubble up in AI development. It's this question of, well, how do you really know if a complex AI model is doing good work? And the twist, what if another AI could be the judge? We're looking at an interesting paper today that explores exactly this idea of AI systems peer reviewing other AIs, especially for tricky stuff like generating and running code. It sounds like it could speed things up massively, but it also opens up some really fascinating challenges, doesn't it? Okay, let's unpack this.
Absolutely. And what's fascinating here is the problem it's trying to solve. You know, AI is getting incredibly good at generating complex stuff code, data analysis, you name it. But will our old ways of checking that work? Simple scores, maybe a quick human look. They often fall short. They just can't keep up with the sheer complexity or the scale. So there's this real pressing need for evaluation that's rigorous, consistent, and crucially scalable. Think of it like automated quality control, making sure these AIs deliver genuinely working solutions, not just things that sound right. It's the difference between something that looks plausible but is wrong and something that's actually correct and functional.
That is such a critical difference. And to get at that, the paper talks about this idea of using AI models as the judges. Now, some of you listening might know LLM as a judge. That's been used quite a bit for checking conversational AI, right? Like, you might have an LLM judge look at multiple choice answers and pick the one that's, quote, correct and follows the required format directly. Good for tech stuff.
Exactly. That works well for text coherence, style, correctness, and language. But the big leap this paper focuses on is agent as a judge. And this isn't just about the text anymore. It's about judging the functionality, the performance. Did the agent actually do the task? So imagine an AI agent is asked to build, say, a small web app. An agent as a judge wouldn't just read the Python script. It would try to run it. It might say, okay, this output is better because, quote, it runs and generates the required files. It worked. Whereas another output, maybe it didn't generate useful code, likely due to website access issues. See the difference? It's focused on execution.
Yep.
And for you listening, this is huge because it's about getting AI that delivers reliable working tools, not just fluent nonsense. Like you said, the difference between describing a meal and actually serving it.
Great analogy. Yeah. And okay, for an AI judge to do that kind of functional check reliably, it needs really good training data, right? A solid foundation. Which brings us to this Dev AI dataset they built. And what really jumped out at me was how carefully they put it together. This wasn't just scrape data. It went through multiple rounds of manual refinement, specifically 2 rounds of comprehensive review and edits. And get this, each round was by a different person. They were looking super closely at things like logical consistency of queries and requirements, making sure the language was clear, not ambiguous, and that the tasks actually fit the domain. And they found and fixed, quote, a moderate number of errors. Just shows how tricky creating this ground truth is. Here's where it gets really interesting, that level of human effort.
Oh, absolutely. That rigor is key. And the richness of the DevAI dataset goes beyond just the task description. It includes all this auxiliary information, these detailed requirement categories. It adds so much context. For example, tasks get tagged with practical things like, is Kaggle app being needed? Details an agent actually needs to function.
Right, practical stuff.
And also AI subfields, computer vision, NLP, supervised learning, RL, plus other tags like is training needed or is web navigation needed. It tells the agent how to approach the problem. And then even within a task, the requirements are categorized. Things like, let me see, 1, data seed environment setup, 2, data processing, 3, the ML method itself, 4, saving models, 5, performance metrics, even 6, human-computer interaction, and 7, visualization. It's comprehensive.
Wow, that's a lot of detail.
It reflects real-world complexity. Like one example task name is 25 speech emotion recognition CNML STM RABDAS deal. Instantly tells you, okay, CNNL STM model, probably for sequential audio data, uses the RAVS dataset, needs solid audio pre-processing. That detail lets the judge assess not just if the output is right, but if it was achieved correctly using the right methods and resources.
That level of detail makes sense for quality, but it does sound incredibly human-intensive to create initially. Is that setup sustainable, or is it just the bootstrapping phase?
That's a really good question. I think it points to the sort of hybrid reality here. Yes, building that initial dataset takes serious human effort, no doubt. But the idea is that investment gives you a robust ground truth to train a judge that can then operate at scale. And crucially, humans don't just disappear after the data set is built. They're still vital. The paper talks about a second round of evaluation where humans are absolutely key. This is where human evaluators step in. Especially when they disagree with the AI judge's assessment, they discuss why. And that discussion is powerful because, as they put it, it helps reduce human bias by examining each other's thought processes thoroughly.
Ah, so they're checking each other and the AI.
Exactly. The idea is that the final consensus results are considered trustworthy. Because, and I like this phrasing, it is unlikely that all three evaluators are convinced by the same mistake or the same cognitive bias. And it's not a quick check-in either. They mentioned the three human evaluators spent 9.5 hours together on this second round.
9.5 hours.
Yeah. It really underscores this hybrid model, doesn't it? You combine the AI's speed and scale with human depth, nuance, and that ability to catch subtle things. It's like a safety net for the AI judge itself.
A human safety net for the AI judge. I like that. Okay, so combining strengths for the best result. Let's zoom in on the agent as a judge itself. How does it actually give its verdict? What does that look like? From what I read, it seems pretty direct, quite objective. For each requirement it's judging, it gives one of two outputs, right? Either satisfied, saying, yep, the agent did this, and here's a quick explanation of how, or unsatisfied, meaning, nope, it didn't meet the requirement, and here's specifically why the deficiencies. All evidence-based.
Precisely. Clear, objective judgments backed by evidence. And that evidence comes from a really deep look at the agent's actions. The required output format for the review process is very detailed. It makes sure the judge sees everything. It demands highlighting relevant steps, like which files were created or changed. Plus, crucially, any environmental feedback, such as error messages, execution results, or other issues encountered.
So logs of what actually happened when it tried to run things.
Exactly. And it also needs to pinpoint whether any problems occurred that might affect the functionality or success of these files. So you get the whole picture. What the agent tried, what happened, any errors, the final state. It's an audit trail. That's vital for understanding why something worked or didn't, not just the final outcome. Now, shifting gears slightly, when they looked at the judge's performance, how well did the AI judge actually do? They used a metric called alignment rate, basically. How often did the AI judge agree with the human consensus? And they had this initial hypothesis, right? They thought maybe if the judge wasn't performing perfectly, it was because its search component wasn't precise enough. They were using BM 2.5 initially, which is more of a traditional keyword search. Good, but maybe not great at understanding nuance.
Okay, so they thought a better search would make a better judge. Makes sense.
That was the theory. So they tested it. They swapped out BM 2.5. They tried SentenceBERT, which is much more advanced, understands semantic meaning.
Right, context aware.
And they also tried fuzzy search, which is, well, less precise, but might catch near misses.
And did the fancy search help? Did SentenceBERT nail it?
Nope. Surprisingly, neither the super smart SentenceBERT nor the fuzzy search actually improved the agent as a judge's performance. The original BM 2.5 setup had an alignment rate of 86.06%, and the others didn't beat it.
86%. Huh. That is surprising. Why wouldn't better semantic search help?
Well, that's the million-dollar question, isn't it?
Yeah.
It really challenges that assumption that smarter text understanding always equals better overall performance. For you listening, one possible reason is that judging functional code execution might not primarily be a text understanding problem. Maybe the bottleneck isn't figuring out what the requirement means semantically. Perhaps it's more about interpreting the complex state of the execution environment or the subtle functional correctness of the output, things that go beyond just matching words.
So the search finds the right concepts, maybe, but struggles to verify the actual execution.
That could be part of it. A search algorithm finds relevant text, but assessing if code ran, generated the right file, avoided specific errors, that might need different capabilities beyond just search precision.
So that 86.06% alignment, well, 86% sounds, pretty decent for automating something this complex. That other 14% is still quite a gap, isn't it? Especially if you're relying on this for critical AI development. Errors could slip through or correct solutions might get flagged incorrectly. It still feels like you need that human safety net we talked about.
I think that's exactly right. It suggests we're not quite at the point of fully autonomous AI quality control for these really complex functional tasks. 86% is a massive step towards highly efficient, automated review, a powerful first pass. But it also highlights that for the really tricky cases, the ambiguous requirements, the high-stakes deployments, human oversight, human judgment still seems necessary.
Right. It's progress, significant progress, but maybe not the final word yet. So what does this all mean? We've gone from the basic idea of AI judging AI LLM as a judge for text, agent as a judge for function. We saw how crucial that meticulously built, human-reviewed DeepAI dataset is as a foundation. We looked at how the AI judge works those satisfied or unsatisfied verdicts backed by execution evidence. And then the performance twist that more advanced search didn't necessarily improve accuracy, leading to that 86% alignment figure.
Exactly. And that leaves us with a really provocative thought to chew on, doesn't it?
Yeah.
Think about the implications if or maybe when we get an AI that can consistently, objectively peer review highly technical work like code generation or even new AI model architectures. What could that do for the sheer speed of innovation? Could we develop and deploy safer, more reliable AI much, much faster?
Potentially transformative.
Potentially. But then, what happens to the roles of human developers, human reviewers? Does the AI become the ultimate quality gatekeeper? Or, perhaps more likely, does it always stay a collaborative process? Maybe it evolves into something even more sophisticated, a kind of human-in-the-loop system where the human's role shifts to judging the AI judge, refining its abilities, overseeing its decisions, pushing the boundaries of what human-AI collaboration really looks like. The possibilities are huge, and, well, we're seeing them start to take shape right now.